Traditional accounting lists inventory as a current asset, but a warehouse of unsold goods requires rent, insurance, and security. That physical stock actively drains cash. To pass the advanced costing section of the CPA exam, you have to invert that intuition. Inventory is a liability, masking itself as an asset. Modern operations solve this trapped capital problem using just-in-time, or JIT, systems. People often assume JIT means waiting until the last possible second to order supplies. In practice, it is the systematic, mathematical elimination of waste from the entire production cycle. This system relies on two highly coordinated pillars: demand-pull production on the factory floor and relevant cost purchasing in the supply chain. CPA candidates must demonstrate how a factory's physical layout dictates the financial math of its supplier selection. We start with the traditional baseline: Materials Requirements Planning, or MRP. MRP operates as a push-through system. Managers calculate demand forecasts, and production begins based on those predictions, rather than waiting for verified sales. When factories build to forecast, raw materials are pushed down linear assembly lines into massive inventory buffers. If a machine miscalibrates, defective items get buried deep inside holding pins. The error isn't discovered until those units reach the next workstation. The JIT framework replaces this with a demand-pull system, where the chain reaction runs backward. Production is triggered exclusively when a customer places an actual order at the end of the line, pulling exactly one unit forward from the preceding station. To make that flow possible, factories tear down long assembly lines. They group different equipment together into tight U-shaped clusters, known as manufacturing cells. Working inside these cells means employees can no longer specialize in just one task. They must be cross-trained to operate multiple machines and perform routine maintenance across the entire U-shape. This cellular layout immediately exposes a severe financial constraint: setup time. That is the cost and labor required to recalibrate equipment for a different product run. Because JIT operates with zero inventory buffers, you cannot produce in massive batches to spread out that setup cost. Factories aggressively engineer machinery to drastically lower setup times, making very small batch sizes economically viable. These smaller batches provide an instant quality control mechanism. With only a few items moving between stations at a time, workers trace and fix defects immediately, before the error can multiply. By physically reorganizing into cells and cutting setup times, a firm shrinks its manufacturing cycle and eradicates rework costs. Operations drive the accounting. A zero-inventory, demand-pull system relies entirely on the precise arrival of raw materials. If external suppliers fail, the factory instantly stops. This introduces the central mathematical trap of JIT purchasing, evaluating a vendor based solely on their unit invoice price. Let's test this using a manufacturer named CD World, choosing between two compact disc suppliers, Sontec and Denton. At face value, Denton offers an invoice price of $13.80 per package, beating Sontec's $14.02. The standard intuition suggests Denton is the superior financial choice. This table shows the total relevant cost framework, which models the complete financial matrix of doing business with a supplier. We start with the base purchasing parameters for our 13,000 required units. Without safety stock to absorb shocks, any unreliability from a supplier triggers immediate compounding penalty costs that must be factored into the purchase. The first hidden penalty is inspection costs. Sontec has a perfect delivery history, requiring zero inspection. Denton's inconsistent quality forces CD World to inspect every package, adding an ongoing 5-cent per unit fee that totals $650. The second, more dangerous penalty is stockout costs. Denton's delivery delays force the factory into 360 emergency rush orders per year. Sontec's reliable schedule results in only 150. That difference drives Denton's stockout costs up to $1,440. The final and most severe penalty comes from customer return costs, caused by poor component quality. Denton's 2.5% failure rate adds a $3,250 return cost penalty that Sontec avoids entirely. Aggregating these variables reveals the true financial picture. Denton's hidden penalties push its total to $185,253, making Sontec the cheaper option at $183,380. Denton's initial discount is negated by the operational penalties it introduces into the system. In a JIT environment, a higher initial unit price is often a sound investment, as it systematically removes the costs associated with unreliability. JIT production in a manufacturing cell and JIT purchasing in a supply chain are completely interdependent. You cannot run a demand-pull factory with unreliable vendors. In its ideal state, a high-quality supplier delivers materials perfectly timed to the manufacturing cell's exact needs, bypassing the storage warehouse entirely. Warning tone. When you sit for the board exam, question writers will intentionally bait you with simple unit cost comparisons. Immediately scan any JIT word problem for 3 specific variables hidden in the text. First, identify the opportunity carrying costs. Calculate the exact cost of capital tied up by holding excess inventory in a warehouse. Second, locate the setup cost reductions. This is the operational trigger that proves the factory can afford to produce in smaller batches. Third, isolate the stockout and quality variables. Calculate the exact financial penalties for rush orders, inspections, and customer returns. Never take a quoted purchase price at face value. Build the complete relevant cost matrix before selecting an answer. Mastering advanced costing means understanding that inventory is a dynamic liability to be systematically eliminated, not a static asset to be stored.